Hello and welcome to the class. Today we are going to talk about preservatives, colors permitted and prohibited in India. First of all, the introduction. Food preservation is the science which deals with prevention of decay or spoilage of food by using certain methods so that the product can be stored in a fresh condition for future use. Freshly prepared products lost their color, flavor and quality with passage of time because bacteria, molds, yeast cause fermentation. Color, flavor, etc. adversely affected by enzyme action. Reaction of chemicals present in the pulp or juice with one another developing of flavor and color. Development of bitter taste by the glucosidyl material present in the juice when they come in contact with air. Example, some of the citrus fruits juice extracts, if not preserved immediately, develops a bitter taste. Metal from the equipment may get mixed with the juice and may spoil taste and flavor. Various methods are used for preserving fruit and vegetable products. That is, using high temperature, low temperature, drying, using sugar, salt, etc. Preservation using high temperature is generally a very popular method of preservation. But products preserved by this method may develop off flavor and there may be loss of nutrients in the process. Moreover, the contents are to be consumed immediately after opening of the seal. Preservation using chemicals has several advantages over other methods of preservation. Since no heat is applied, there are no much quality changes like loss of nutrients and off flavor development, etc. Moreover, the products can be consumed for a few days even after opening of the seal. Consumers prefer good, attractive color of the products. Hence, in order to enhance the color of the products, artificial colors are generally used commercially. Moreover, during processing, the products may lose their original color, which may be compensated by adding artificial colors. First of all, let us discuss about the preservatives. Preservatives generally control the microbial spoilage of food. They are of two types: Class 1 preservative and Class 2 preservatives. Salt, sugar, acetic acid, oils, alcohol that originates from natural source comes under Class 1 preservative. All chemical preservatives are classified under Class 2 preservative. The chemical preservatives interfere with the mechanism of cell division, permeability of cell membrane, and the activity of enzymes. However, care should be taken in its use. Indiscriminate and overdoses of its use may be injurious to health. According to British Food and Drug Act 1928, a preservative is any substance which is capable of inhibiting, retarding or arresting the process of fermentation, acidification or other decomposition of food, but does not include common salt, saltpeter, that is sodium or potassium nitrate, sugar, acetic acid or vinegar, alcohol or potable spirits, spices, essential oil or any other substance added to the food by the process of curing known as smoking. Many chemical preservatives are available for uses. However, not all preservatives are permitted for use. Two of the preservatives that are mostly used all over the world, including India, are sulfur dioxide, including sulfides, benzoic acid, including benzoids. Sulfur dioxide. It is used in the form of its salts like sulfide, bisulfate, and metabisulfite. Most commonly used stable source of sulfur dioxide is the potassium metabisulfite. It being in solid state, its use is easier as compared to liquid or gaseous sulfur dioxide. Sulfur dioxide has a good preserving action against bacteria and mold and have inhibitory action against enzymes responsible for non-enzymatic browning or discoloration and is widely used for preserving juice, pulp, nectar, squash, crush, cordial and other products. It has antioxidant and bleaching properties which helps in retention of ascorbic acid, carotene and other oxidizable compounds. According to FPO, in fruit juice, the maximum amount of sulfur dioxide allowed is 700 ppm. In squash, crush and cordial, it is 350 ppm and in RTS and nectar, it is 100 ppm. However, because of its bleaching action, sulfur dioxide cannot be used in some of the naturally colored fruit products like those made of falsa, pomegranate, strawberry, colored grapes, plums, etc. It cannot be used in products that are to be packed in tin containers because it reacts with tin to produce hydrogen sulfide gas which produces a disagreeable smell. The hydrogen sulfide thus formed reacts with iron of the tin container to produce blackish discoloration. Further, sulfur dioxide corrodes the tin containers making pinholes. The sulfur dioxide used in freshly prepared beverages aids some taste and odor. But this is not a serious defect for some of the beverage which are used after dilution. Benzoic acid. Benzoic acid is more effective against yeast than against molds. Since benzoic acid is partially soluble in water, its salt sodium benzoate is used. In the presence of carbon dioxide and acid, the antibacterial action of benzoic acid is increased. However, the lactic acid and acetic acid fermentation is not stopped by benzoic acid. The quantity of benzoic acid required depends upon the quantity of acid contained of the product. The FPO specification for the permitted level of sodium benzoate for RTS and nectar is 100 ppm and in squash, crush and cordial is 600 ppm. A disagreeable burning taste develops when sodium benzoate is in excess of 0.1%. Sodium benzoates generally darken the product during storage. Therefore, it is generally used in colored products made out of fruits and vegetables like tomato, falsa, pomegranate, plum, watermelon, strawberry, colored grapes, etc. A number of other chemicals that were used as chemical preservatives, that is hydrogen peroxide, formaldehyde, halogenated acetic acid, salicylic acid, etc. has been banned nowadays. While using the chemical preservatives, it should not be added directly to the juice. Rather, it should be mixed with little quantity of juice or water till it dissolves and should be mixed with the whole juice. It has been found that the undissolved preservatives settle at the bottom. As a result, fermentation starts before the action of the preservatives takes place. Food colors. Food coloring or color additive is any dye, pigment or substance that imparts color when it is added to food or drink. They come in many forms consisting of liquids, powders, gels and pastes. Food coloring is used both in commercial food production and in domestic cooking. Due to its safety and general availability, food coloring is also used in a variety of non-food applications including cosmetics, pharmaceuticals, home craft projects and medical devices. Natural colors. Colors that are exempted from certification include pigments derived from natural sources such as vegetables, minerals or animals. Nature-derived color additives are typically more expensive than certified colors and may add unintended flavors to foods. Examples of exempt colors include annatto, beet extract, caramel, beta-carotene, turmeric and grape skin extract. The pigments that are generally found in plant-based foods are chlorophyll, carotenoids, anthocyanins, flavonoids, anthocyanins, tannins, quinones and xanthones, betalains and synthetic colors. Chlorophyll. The green coloration of the leafy vegetables indicates the presence of chlorophyll. Chlorophyll is of two types, chlorophyll A and chlorophyll B, and is present in the ratio of 3:1. During storage, there is always some deterioration of chlorophyll. Carotenoids. Carotenoids are present in many fruits and vegetables like carrot, pumpkin, mango, orange, etc. They are orange-yellow pigment and are fat-soluble in nature. For use as a natural food color, carotenes are extracted from annatto, saffron, paprika, tomato, etc. Beta-carotene, the precursor of vitamin A that show vitamin A activity, can be extracted from carrot, butter, fat and palm oil. The fresh yellow-green color of spring leaves is due to the presence of carotenoids together with a small amount of chlorophyll. Anthocyanins. At lower pH, the color of anthocyanin is an intense red which changes to orange and red to blue or purple as the pH value rises. Sulfur or sulfur dioxide rapidly bleaches the color of anthocyanin. Removal of sulfide by boiling and acidification results in the regeneration of anthocyanins. Flavonoids. Flavonoids are water-soluble polyphenolic substances and are similar in structure with anthocyanins. The yellow-white or creamy white color of potato and cauliflower are due to flavones and anthocyanin pigments. Synthetic sweeteners are prepared from flavones that occur in citrus plants. Anthocyanins. Anthocyanins are glycosides and are creamy yellow, creamy white or yellow-white water-soluble compound and occurs in cell sap of some fruits and vegetables like potato and cauliflower. Tannins. Tannins are also known as tannic acid or gallotanic acid. The fruits containing tannin with white flesh turn brownish when they are cut and exposed to air. Example, brinjal, bottle gourd, apple, etc. Hence, tannins are responsible for enzymatic browning and astringency of foods. Quinones and xanthones. Anthraquinone derivatives consist of the largest group of pigments found in the cell sap of flowering plants, fungi, bacteria and algae, with color ranging from pale yellow to almost black. Mangiferin, which occur as a glycoside in mangoes, are a group of yellow pigments called xanthones. Betalains. Betalains are found in red beet, in cactus fruits, pokeberries and in number of flowers like bougainvillea and contain the red and yellow pigments. There are various naturally occurring coloring pigments that are safe for consumption. FPO India in 1955 has permitted the use of the following natural and synthesized pigments for use in food. That is annatto, caramel, carotene and carotenoids, chlorophyll, cochineal and carotenoids, curcumin, lactoflavin, rattan jod and saffron. Carrot oil and juices of fruits like strawberry and cherries that develops attractive pink color are generally used for coloring ice creams. Dehydrated beet powder are also included under permitted colors. Synthetic colors. By 1900s, bulk of chemically synthesized colors were derived from aniline, a petroleum product that is toxic. Originally, these were dubbed coal tar colors because the starting materials that were obtained were from bituminous coal. The first coal tar dye was developed in 1857. Prior to that, only natural food colors were used for coloring food products. However, severe restrictions were imposed on the use of certain synthesized food colors. FPO has allowed the use of the following coal tar dye for use in foods. Synthetic red colors, they are carmozine, fast red, amaranth, erythrosine. Yellow colors, they are tartrazine, sunset yellow FCF. Blue colors, they are indigo carmine, brilliant blue FCF. Green colors, they are fast green S, green FCF. The dyes that are used in food should be very much pure and free from harmful impurities, should not contain more than 20 ppm chromium and 10 ppm copper, 1 ppm arsenic and 10 ppm lead. They should have high solubility to have highly concentrated solutions of a particular color. It should retain color for a long period of time without fading. Now, let us talk about certified colors. Certified colors are synthetically produced and are used widely because they impart an intense uniform color, are less expensive and blend more easily to create a variety of hues. There are 9 certified color additives approved for use in the United States. Certified food colors generally do not add undesirable flavors to foods. Now coming to banned colors. The following coloring matters are banned from using as food colors as per public health by the Ministry of Health UK. Metallic colors. Compounds of any of the metals antimony, arsenic, cadmium, chromium, copper, mercury, lead and zinc. Vegetable coloring matter, gamboge, coal tar colors, picric acid, Victoria yellow, Manchester yellow, Aurantia, orin. In India also, use of certain colors has been banned. triphenylmethane dyes like acid magenta 2 and blue VRS, which were used in tomato ketchup and canned peas respectively, has been deleted from the list of permitted colors. However, fast green S and green FCF have been recommended instead of blue VRS. Some dyes like red 6B, red FB and brilliant black have been listed as harmful. After all the discussion we had today, we can conclude that chemical preservatives are most widely used chemicals to protect fruit and vegetable products from deterioration caused by microbial infection or due to action of enzymes. Of the various chemical preservatives, most commonly used and permitted preservative in India are potassium metabisulfate and sodium benzoate. However, one should be very much careful in its use. Doses used in excess of recommendation may lead to health hazard. Colors are added to the products to make it attractive to the consumers. Colors used may be natural or artificial. The most commonly used natural colors are chlorophyll, carotenoids, anthocyanins, tannins, etc.